Okay, so today we're going to be building a game of Mario in pure JavaScript, HTML, and CSS. No fancy frameworks, no Canva, no. We're doing this to actually practice our JavaScript skills. So this is the finished game. We've got a little game of Mario. We have Mario himself. He can jump, he can kill the evil little mushrooms, and he can bounce into surprise blocks, which will either give him a mushroom in which he grows bigger for a certain amount of time, or get coins. So it's a surprise each time. We of course also have pipes to let him go to next levels. So yes, we're gonna have 2 levels in here, but don't worry, this game is all about practicing your fundamentals and gaining knowledge so that you can take this game, make it your own, add as many levels as you want because you will have the knowledge to do so. So once again, as a reminder, this is to practice your JavaScript, to really master your JavaScript. It's going to assume you have knowledge of objects. It's going to assume you have knowledge of JavaScript methods. If you don't, however, don't worry. Please try to code along anyway. You always have my 12-hour free coding course, which you can go back to, where we do go into these in a lot more detail. Okay, once again, this assumes a certain level of JavaScript. But if you're feeling brave, try it anyway. Who knows? You might be a coding prodigy. And if you're interested in deploying this game onto the internet, or deploying anything you want really, I'm going to show you where to go for that. This is actually outside of the scope of this tutorial, but if you finish this project and want to deploy it, you could do so with Savala for free. So make sure to go to the link below and bookmark it. Simply sign up to the cloud platform and deploy straight from GitHub, GitLab, or Gitbucket in minutes. So in other words, save your code to GitHub like so, and deploy with Savala onto the internet. Easy. Whether you're launching your first side project like this one or scaling a serious application with sensitive data in the future, Savala, which is actually built on Google Cloud Platform and backed by Kinsta, offers added benefits such as security, all-in-one intuitive dashboard. Okay, so what are we waiting for? Let's get to it. Let's build out Mario. Okay, so let's do it. Let's build a super simple game of Mario using just HTML, CSS, and JavaScript. No fancy things like Canva. We're really getting to understand the fundamentals of JavaScript, the language. So let's do it. So let's go ahead and create a new project. I'm going to choose to make this just an empty project. Okay, so we're really starting from scratch. I'm going to call this Mario.js, and this lives in a directory called WebStorm project that lives on the Anyakuba username on my computer. So let's go ahead and create that. Okay, so there we go. At the moment, it's just like this. And I'm going to create a new file. This is going to be an HTML file. I'm going to call it index. We don't need to put the HTML extension because, you know, we selected HTML file. But if you're not, please go ahead and do that. So this is what it looks like. I'm just going to call this Mario.js, just like so. Here's the boilerplate code if you don't have yours in your IDE already. Okay, so that's what it looks like. Next, we're going to create an app.js file. This is going to be for our JavaScript. So once again, I'm just going to do JavaScript file, call it app, and you can put the extension or not. So this will now know to treat this as a JavaScript file. Wonderful. And next, we're going to have to create a CSS file. So this is going to be for our style sheet. So we can just select style sheet, just select CSS, and I'm going to call this styles. So once again, styles.css. So now our code editor knows to treat this as a CSS file because of that .css extension. Great. Now let's link them up. So back in here, I'm just going to use the link element just like so. It's a self-closing tag, and I'm going to do rel style sheet, and then href, and then I'm going to link the styles.css file is in the same directory, okay, so on the same level. So I'm just going to type in style.css to get that file name because it lives in the same place as the index.html. Great. And for the JavaScript, well, I'm just going to put a script tag at the very bottom of my body. And instead of index.js, we need app.js, right? Because we need to go to the app.js file. But we do it after all of the HTML has been read first, which is why this needs to be at the bottom in between my 2 body tags. Okay. So great, we're set up. We've linked up all the files. We linked up the JavaScript file and the styles CSS file. So we are now ready to continue. So in order to make our super simple Mario game, first off, I'm just going to use an h1 tag, and I'm just going to put simple Mario game, just like so. And let's go ahead and put a mushroom there. So wonderful, that's the h1 tag. And then I'm just going to use a div, and this is going to have all our game stuff in it. So I'm going to use the class, a class name of game container. Okay, so that we can essentially style this whole div as some kind of game container essentially. And for now, I'm just going to put in another div, and this is going to be the user interface, which is going to hold the score, the levels, and the lives. So let's give this the class name of UI. And then in here, I'm going to just put divs. Let's put score, and then let's use a span to put the actual score, which I'm going to hard code as 0 for now. We're going to pick out this whole element, the whole span element, okay? And I'm going to give this the ID of score. So we can pick that whole thing out and essentially change this 0 to be a 1 or a 2 or a 3 or a 4. So that's what I'm going to do. You can keep this as a div, or you can put this as a paragraph element. It's really up to you and how you want to style this. So we've got the score, the levels, and the lives. So score, levels, lives. I will say one thing, it's better to have a p element just in terms of it being more semantically correct than using a div, because essentially it is a bunch of text, so a p element would fit much more. Level, I'm going to hard code this as 1, as you don't really start from level 0, and lives, I'm going to also hard code this to 3, just like so. Okay, great. I'm just going to move this over as well for now. In fact, let's just get rid of it. So wonderful. The next thing I'm going to do is just lower this once more, making sure that it is in the game container. I'm going to add a div, and this time this div is going to have another div inside. And let's give this the ID of game area, just like that. And this the ID of Mario. So this is going to be our little Mario. Next, I'm just going to add another div, and this is going to be the controls. So class name controls, just like so. And in here, we're going to have a p element, and this is going to say controls, just like that. Another p element that's going to say arrow key. So this is essentially the instructions on how to move on our board. Move left, right with the arrow keys, and one more p element, and this is going to say down arrow, and down arrow is to enter the pipe, okay, when on top of it. Great. So that is our instructions essentially on how to control Mario. And finally, we're going to have one more, okay, so let's close off the game container, and outside of the game container, I'm going to have another div. This is going to have the class name of game over, so we know that if it's a game over, well, let's have the game over appear quite large. This h2 element is just going to have the words game over, and let's pick it out. I'm going to give it an ID of game over title, just like so. And then let's use the p element to have score. And once again, let's pick it out. So span 0. Let's give this the ID of final score, just like that. And then I'm just going to add a button, and we're going to pick this out later, but let's just have play again on it. And I'm going to give this the ID of restart button, just like that. Great. Okay, so that is our index.html file. We are really kind of done here. Let's move over to the styles next. Because at the moment, if we look at this, so I'm just going to get this up, and then we copy the path, copy the absolute path, and paste it like so. This is what our project looks like right now, just with the HTML and no styling. So let's style it up. So let's go back here. I'm just going to minimize this and let's go to our styles.css file. And let's start picking stuff out by classes and IDs. First off, however, I'm just going to grab the whole body, so the whole body holding everything in. Let's just get rid of any default margin and padding, just in case. And then background, well, I'm going to give this a linear gradient actually, so linear gradient, this is a CSS function, to bottom, as I want the gradient to go from top to bottom. And then I've already picked out two colors. Okay, so I want to go from this color to this color, and you get a nice preview of them there. So that is good. We just need a comma there as well. So all three have a comma in between them. The font family that we're going to use is Courier New. And as a backup, I'm just going to have monospace. Great. And finally, I'm going to use display flex to initiate flexbox so that we can say that everything inside is going to have a flex selection of columns. So any elements inside the body are going to essentially stack up like a column. And then I'm going to also use align items center to make sure that they're centered. Let's also set the height to be 100 viewport height in order for all of this to essentially work. Okay, so now it should all look like that. As you can see, it's centered, it's in a column, and it looks pretty good so far. Let's continue. Now let's pick out the class name of game container. So to pick out a class name, you know what to do. It's .game container, and I'm going to go with background white, or if you want to keep everything consistent, let's use hex. So the hex color code for this would be FFF as a shorthand of FFF 6 times. So you could just put 3 Fs if you want. And then I'm going to give this a border of 3 pixels, so 3 pixel wide border that is solid, not dotted or anything like that, and black. So again, that's the shorthand for writing black, which in full is 3 zeros. But that is the shorthand, so it will be the same. Next, let's look at the border radius. So the border radius, I'm going to just round it off to be slightly curved to be 10 pixels. Now let's pad it out. So I'm just going to give a padding of 10 pixels as well, and a box shadow. Okay, so a box shadow of 0 on the x-axis, 4 pixels on the y-axis, x pixels spread. And then let's also make it black. So at the moment it looks like this. It's very dark. However, we can make it transparent. I'm just going to inspect that. Okay, so there we are. You can also see all the elements here. So at the moment we're signing the game container. If I remove the padding, it will look like that, but we added the padding, and I could just go ahead and remove things if I want, but I think that looks good for now. Great, I'm happy with this. Let's continue. Next, let's style the element with the class name of UI. So that is this one here. And all I'm going to do is just use display flex once more. I'm going to use justify content space between. So that just means that if we look here now and look at the UI, you will see all that lovely spacing in between. If you get rid of it, it looks like that. But if you keep it there, it's spaced out nicely. And that's thanks to display flex. You can't use this without display flex. Okay, great. Let's continue. Now I'm also maybe just going to give it a bit of a margin, but only at the bottom. So you can do so like this. Let's go with 10 pixels. And then also I'm going to change the font size of this to be 18 pixels. And the font weight, just to make it a little bit thicker, is bold. Okay, I'm also going to apply a min width to it, which is going to be 800 pixels, meaning that even if you kind of move it across, let's just refresh this, it will stop at 800. It won't move this across. The minimum width will always be 800 pixels. Great, and that is again of the UI element right there. Let's continue. Now it's time to pick out the game area. So this time we're picking out an element by its ID. So to do that, I'm going to use hash, and that is how we pick out the game area. Okay, so just like that. Now the reason I've chosen to use an ID for this is that we're actually going to be picking this out in JavaScript too, so it kind of needs to be unique. Same for this div right here. Whereas this is more to do with styling and how it looks. Okay, wonderful. So the game area itself, well, I'm going to go ahead and give it a width of 800 pixels, a height of 400 pixels, a background. Once again, I'm going to make it a linear gradient to bottom, and then I've already picked out all the colors. We're going to have a sky, so I'm going to go with this, and then we're going to have the green for the floor. But if you look at it at the moment, I'm just going to refresh, it looks like this. If we want a hard kind of stop and a chop, well, what we'd have to do is just add some other things in here. So it's blue up to 80%, but then at the same time, 80%, I want to turn it to green. So that should fix it. Great. I love that. That's a little hack for you. Okay, now the border of this, again, I'm going to put 2 pixels solid, and this time, let's go with that right there. So a little bit off black, and now we get a nice border to our game area. So this is looking good. And any overflow, if there ever is any, I want it to be hidden. Okay, now let's look at the players. Well, Mario, we're going to pick him out by his ID in JavaScript, but also I'm just going to style him up to have a width of 20 pixels, a height of 20 pixels, a background image. So I actually made this game a long time ago using a framework, which I don't want to use today. So I've already uploaded all the images we need. Please go ahead and take mine. You can take them from the code that I share later. So that is my little Mario, which is in fact 20 by 20 pixels wide. So this image is that. And then I think that should be fine, but just in case, I'm going to give it a Z index of 100 to make sure that it's in front of everything. And for that, we need to put a position of absolute. Great. So let's see if our Mario shows up, and there he is at the moment. Wonderful. Now we also need something for when Mario is big. We haven't added this in our HTML. This is something that we will do in JavaScript. So if an element has the ID of Mario and the class name of big on the same element, well, then let's make him big, right? Let's maybe make him 40 by 40 pixels, so it's kind of obvious. And the background image that we're going to use is actually the same. So let's go ahead and get this URL right here. Great. Now let's get anything with the class name of platform, okay, because there could be a few. And once again, we're going to have a background image for this. It's going to be a URL, and it's one that I have previously uploaded of a platform. So here it is. Please go ahead and take mine. Once again, I'm going to put width and height 20 pixels actually. So all the elements are kind of just going to be the same, to be honest. So there's the platform. I kind of want to differentiate if the platform is on the ground. I want to use a different background image. So I'm just going to copy all this and just delete that, and the background image for this will be here. It's kind of hard for us to obviously imagine this because we haven't built this so far, but just know that there will be platforms of different types. So in fact, maybe it's best to just copy all of this, and I'm going to delete that class name and delete that image. Okay, so that is kind of our template. And when the platform is also blue, so it has the class name, the element, sorry, has the class name of platform and the class name of blue, well then we're going to have a different URL. So the blue platform is essentially this image right here. Now let's also create our enemy. So once again, I'm just going to make the enemy 20 by 20, and the URL for the enemy is going to be this. We're also going to have an enemy that is purple for other levels, and so the URLs of this is going to be a little bit different. Here we go. And we're also going to have a coin, because you know Mario uses the coins. So once again, let's just copy this. Everything's 20 by 20 pixels, but the image for this is of a cute little coin. I can't wait to show you. And for this one, I'm actually going to animate it as well. So animation coin spin is something that we're going to write. It's going to last for 1 second. It's going to be linear, and it's going to be infinite. Okay, so now to define the animation, we're going to need keyframes, and then we're going to get the animation name. So I chose to call this coin spin, and at 0% start of the animation, because you know an animation runs from 0 to 100, we're going to transform, just rotate on the y-axis by 0 degrees, and by the time it's reached a full animation, so the full thing, I'm going to transform, rotate by y-axis 360 degrees. So it's going to literally rotate on the y-axis by 360 degrees. Great, and that should have an L there too. Okay, we are nearly done. Once again, I'm just going to copy this because we need the surprise block, which again is 20 by 20, and the URL for this is going to be this right here. We're going to have a surprise block, however, if it's hit, so if it also has the class name of hit, and on this occasion, it's going to be this right here. If you are curious what these look like, you can, of course, just paste them into the browser like so. So here it is. Here is my little block that I made ages ago in 2021. In fact, there we go. That's what it looks like. Cool. We also need the pipe. So the pipe, this is going to be, again, made of the pipe top, actually. So let's have all the pipe styles. Then we're going to have the pipe top right, the pipe bottom, and the pipe bottom right. Okay, so now I could just quickly add all those in. So the pipe top, the pipe top right, the pipe top bottom, and the pipe bottom right. We should also maybe encapsulate all of these in one pipe element too. So for this, I'm just going to say that the width of the whole pipe is going to be 40 pixels, and the height of it is going to be, I guess, 40 pixels too, right? Because if we have these two stacked up, that should be good. We can always come back to this if we need. So now all the pipe elements, we're going to encapsulate in one whole pipe element that we will give the class name of pipe2. Great. We will be coming back to this file once we actually start working with it. I just want to get all the images here in one place. Next, I'm just going to grab the controls. So simply the controls that we have here. So this div with the class name of controls. And I'm just going to give it a margin top 15 pixels to space it out. I'm going to align the text in the center. And let's just change the font size of this to be 14 pixels like so. So that will now affect the controls here, and they have. I think I'm kind of happy with this now. Next, let's also pick out this whole element, the game over element, by the class name. So dot game over element. And I'm going to give this the position of absolute. So now if we save that, it will go from here to here. right? It's absolute, meaning it kind of overrides everything and appears on top of everything. And if I want to position it 50% from the top, all I would do is go top 50%, just like that. And it will appear 50% from there as the whole element, right? So it's here at the moment. I'm also going to make it have a border of 3 pixels solid. Let's go with white. Okay, so there we go. Let's maybe go ahead and give it a background. We can go with something transparent if we want. So black is this, and by adding the A, we're giving it a 0.9 opacity. So that's what it looks like. Let's also change the text color to be white, so hash FFF. There we go. Let's pad it out a little bit, so padding 30 pixels. Border radius 10 pixels. Text align center. And let's just make sure it's always in the front. So I'm going to go Z index 1000, really kind of go overboard to make sure that it does. Okay, so now with that, it will look like this. And you can change the opacity if you want. If you go 0.5, it will appear a little bit more opaque. So it's really up to you where you want to take this project. Okay, great. We can also style the button, so perhaps let's do that. I'm just going to grab the button, so this button right here with the ID restart button. So restart button. Let's give it a background color of hash FF6B6B. To make the color of the font white. I'm going to go with border none, border radius 5 pixels, font size 16 pixels, margin 10 pixels. Just move that up. So that looks much better. I'm happy with that. We can also add an on hover effect. So if we want to change what this looks like, if we hover over the button, we can change the background color if we wish, maybe to FF5252. So kind of similar, just more. There we go, red. I love it. Okay, so that's what it looks like at the moment. Now, because we will be displaying this game over pop-up in JavaScript, you can pick things out by their class name. However, it's best to keep this an ID and keep it unique. So I'm actually going to go ahead and change this right now to an ID. Okay, so giving this whole div the ID of game over, meaning that we need to change it here as well to an ID. So just change it to a hash. Visually, that won't change, but for us, moving on, it makes more sense when we start working with the JavaScript. I love it. Let's do it. Okay, so we will be coming back to this page as there's a few more things I will be adding. However, for now, let's move on to the JavaScript. Okay, great. Okay, so first off, I'm just going to start with the game constants. This is going to be things like gravity, jump force, move speed, and enemy speed. So const gravity, 0.5, const jump force equals -12. We can always change these later if you want to increase the gravity, increase the jump force, or increase the move speed. Let's make this 2.5. And then we're going to have enemy speed as well, and make this out 1. So those are our constants, okay? That is something that we use throughout the game, and it won't change. Now let's write some game state variables. So let game state. This will change. This will continue to be updated. So the game state is going to be an object that's going to hold a bunch of information, such as our score, which at the moment is going to be 0, the level, which at the moment we're going to start off with 1, and the lives, which we're going to start off with being 3. Next, we're going to put game running as true, because the game is running. The keys, which we will come back to, this is essentially the keys that you're going to be pressing on your keyboard. So once again, the game state is just one object that looks like this, and essentially is our entire game state for the Mario game. Now let's define the player object. So let player, and once again, this is going to be, like I said, an object. And first of all, let's actually have the element, and we're going to assign something to the element value. We're going to go into our document, so into our document here, kind of essentially, and we're going to use a JavaScript method called getElementById. And we're going to look for the element in here with the ID of Mario. So we're going to grab the whole element by its ID, Mario. Okay, making sure to spell it exactly the same. So now that whole div has been assigned to element, which lives in the player object. Great. Let's also here assign what we want the X value of the player to be on the game board. We want it to be 50. The Y, we want to be 300. So X is this way, Y is that way. We're also going to define the width here, which we know is 20 pixels, but for the JavaScript, it doesn't know that. So we're going to go height and width 20. And then we're also going to have something called velocity. So the traveling velocity of X, the X-axis, which we're going to start off at being 0, and also velocity Y, which is also going to start off being 0. We'll start off with being grounded as false, because the player is going to drop from the sky. Big, he's also going to not be big, so let's start off with false. And there's something called the big timer, because if you've ever played Mario, you should know that the bigness of Mario does run out. Okay? Great. So that is everything assigned to the player object. Great. Let's move on to the game objects arrays. So let game objects, and this is again going to be an object, and in it it's going to hold the game's platforms. It's going to be an empty array for now. The enemies, which is going to be an empty array for now. All the coins in the game, so here they go, obviously empty for now. The surprise blocks, again empty for now. And the pipes, empty for now. But essentially that's what we're going to be working with in this game. Let's make sure to spell surprise correctly. Great. Okay, we're only going to have 2 levels in this game. You can, after this, I have to show you how to make 2 levels. You can actually go ahead and add as many as you want. So const levels equals, and it's going to be array, and the first object is going to be our first level. So in fact, maybe let's go ahead and write that level 1. And level 1 consists of platforms. So exactly like we saw up here, we're now going to actually build this out. So this is going to be an array, and my platforms are going to exist on, we're just going to define where. So on the x-axis 0, y-axis 360, we're positioning the platforms essentially. We're going to say this platform has a width of 400 and a height of 40. And the type of platform this is going to be a ground platform. Okay, so this makes sense why here we wrote platform ground. And next we're going to have the same thing. So once again, I'm actually just going to copy this, and we're going to essentially just change these values here. So let's have 1. Let's have a total of 5. 3, 4, 5. X is going to here be 500. Y-axis is going to be 360. The width of this is going to be 300, and the height of this is going to be 40 again. And let's make this a ground platform. The next platform, we're going to have a floating one. So this is going to be 200. This, let's put it 280. We can always change these after we've done it. This has kind of already been planned out by me. And the floating one, visually it looks the same as the ground one, but for us it's best to kind of differentiate these. But however, it does mean that I'm just going to copy this and put floating here, even though it looks exactly the same. We're going to have different class names for it so we can differentiate them in JavaScript. Okay, great. 300, y 240, width 60, height 20. Again, there's going to be a floating platform. X 600, y 280, width is going to be 80, height is going to be 20, and this again is going to be a floating platform. So once again, in level 1, I've just mapped out exactly where on that level every platform is going to be. Next, let's map out the, you guessed it, the enemies. So let's copy that and let's put our enemies in here. Each enemy is going to be an object. It is going to have an x-axis once more. So 250, y-axis is going to be 344. And then the type of this enemy is just going to be the normal enemy. In fact, I'm just going to define it as brown. So in fact, maybe here also where the enemies, just to make our lives a little bit more clear, enemy brown will show up as this, and enemy purple will show up as that. So that's one enemy on level 1. Let's just have 2. I'm just going to change this to be 550 this time and keep the y-axis the same. Next, you guessed it, let's look at coins and what kind of coins are we going to have for this, because there's just one type of coin really. Let's just have an x-axis and a y-axis. So that's where my first coin is going to appear. And then let's have maybe 3 total. So 1, 2, 3. Let's change this to be 320 and this to be 620. I'm just going to move them around like that. What's next? The surprise blocks. So in fact, maybe let's just copy those 2 things, and there we go. The surprise blocks. I'm just going to have one here. It's going to show up on x-axis 350, y-axis 220. The type of this, so I'm just going to define what's going to pop up inside. It's going to be a mushroom. And the pipe is going to show up at 750, 300. Great. We haven't added the image of mushroom to our style CSS file, but we will do that later. Okay, so that is one level. Let's do another one. So whenever the object finishes, we're going to put a comma and essentially define level 2. So once again, it's an object. And in fact, we could just go ahead and copy all this, because that is exactly what we're going to be filling out. Okay, so let's do it. Once again, let's go X, Y, width, height, and type. Okay, so all the types on level 2 of the platform are going to be blue. And let's go ahead and have 9, 2, 3, 4, 5, 6, 7, 8, 9. I have already pre-planned this for you, so if you don't like how this looks, you can always change the position of everything that you see here. So maybe it's easier for me to copy here. I am just copying from a pre-made sheet, but I have all these already stored because this took a lot of time to plan out. I'm essentially just saving you a bunch of time by giving you a kind of already drawn out level. But like I said, if you want to add more levels, please go ahead and do so. Okay, in fact, let's just have 8. Here, I'm going to go 360, 360. 300, 280, 260, 240, 280, 200, 200, 40, 40, 40, 40, 60, height 40, 40, 20, 20, 20, 20, 20. Great. Now for the enemies, so once more we're going to have X, Y, type, and then let's have 3 enemies on this level. So I'm going to have one at 350, 344, type purple this time. X-axis is going to be 650, 344, once again purple, and X here 570, 264, purple. Okay, so there we go. Next, let's also do the coins. So in fact, maybe I'll just copy and paste all these coins here to save us time. Those are the coin areas that I picked out. And this time we're going to have 2 surprise blocks. One is going to have a coin and one is going to have a mushroom and 1 pipe only. So here is the location of that pipe. Great. So those are 2 levels. Let's move on. I think it's time to actually show everything we've done so far. So I'm going to initialize. Okay, great. So function init game. That is my function. I'm going to write another function called load level, and I'm going to look into the game state, get the level. Okay, so if we go into game state right here, game state dot level, because there's an object, so we go into the object by adding a dot to get any of these properties. Game state dot level will give us the value 1. Okay, the integer value of 1. And then I'm also going to write another function to game loop. Cool. So let's go ahead and write the function load level next. So function load level, and then whatever we pass into here, I'm just going to go ahead and call it level index. So in this case, we're passing through a 1. This is just a little helper that shows up, which we can disable. Now, first off, I just want to check that if the level index is larger than or equal to the level's length. Now, there is a bit of an issue here because imagine we are level 2, right? Well, we only have 2 levels in our levels array. So technically, if we pass through a 2, that does equal the length of the levels array, which is 2, which would mean it would be a game over. That is not what we want. So actually what I'm going to do is just add a -1 to the level index. So to start counting at 0, however, let's go ahead and do that all the way here in the load level function. So that level index is actually being passed through as a 0 now. So if it goes to 1, which is essentially level 2, it is still lower than the level's length. So we will be good to play. And if it of course goes over, then it will show a game over. Okay? So hopefully that makes sense. Now, if we are below that, and so essentially level index does not go over the level's length, we are happy to play the game. I'm just going to start off by clearing the existing objects. I'm going to write another function called clear level, which we have not written yet. So I'm just going to comment that out for now. And now let's actually get the level. So const level, let's define it. We're going to go into our levels array, and we're going to pass through the level index. So if it's a 0, we'll get back the first item and assign it to level. Next, I'm also going to define the game area. And for this, we're going to go into our document, into our whole document here, and get the element with the ID of game area. So let's use get element by ID and pass through the game area. Easy. Okay, so now I'm going to also reset the player. So wherever the player is, our little Mario, I'm going to get the player and get its x-axis, because as we know, player is an object that we wrote above, and I'm going to assign it to 50. Let's also get y and assign it 300. Player velocity x is going to be 0. Player velocity y is going to be 0. Player big is going to be false. We're starting off as small. And player big timer will also start off as being 0. Great. Let's also clear any class names that might be assigned to the player. So for example, if he's currently big, class name, it's going to clear it to be an empty string. And we're going to update element position. This is a function that we are yet to write, and we'll just pass through the player. Just a few things actually. So the player element, the player x-axis, and the player y-axis. So again, this is a function that we are yet to write. So I'm just going to comment that out for now. Let's move on. So outside of this function, I'm going to write another function called, you guessed it, update element position, in which we pass through the element, the x-axis and the y-axis. And I'm just going to grab the element style left and just use x plus px as we are working in pixels. So we're getting that element, essentially our Mario, and using style to manipulate the style position left. And we're passing through whatever that is. So in this case, it's 50 pixels. We're also going to have to add a position of absolute to Mario. So let's find Mario here. That's already been done for us, because otherwise we would not be able to add left, right, top, and bottom as we are doing now. So we've just added left, and then also let's do top. Okay, and for this it's y. Great. So we've now written that. Let's uncomment it out here. I'm going to keep that like that. Okay, so let's give it a go. We are going to have to call this function, of course. So let's start game. And I'm just going to call that. And let's see what happens. Okay, so wonderful. Game loop is not defined. That is fine. Let's just go ahead and comment out game loop for now. What we've essentially done is assign an x and a y axis to Mario. Okay, it is absolute, so it's taking in the whole page into account. However, we just want this in the game area. So let's go back to styles. Let's find our game area, and I'm going to add a position of relative to the game area, meaning that Mario will now appear inside that game area, 50 pixels and 300 pixels from the top. Great. So we've essentially kind of started our game by placing Mario exactly where he is. Wonderful. I love it. Let's continue. So let's go back to this file right here. Okay, now let's continue by going back into this function, so the load level function. And what I'm going to do is actually create the platforms for this layer. So create platforms, just like so. And I'm going to get the level, and from the level I'm going to get the platforms. And for each platform, that lives inside of that array, I'm going to essentially create an element out that data. So maybe let's call this platform data instead, as it is just a bunch of data, and let's define our actual platform. So remember the data, it had the X and the Y and the width and the height. We're actually going to use that. We're going to write a function called create element, and we're going to create a div, and that div is also going to have the class name of platform, and we're going to go into that platform data once more to get the type. Okay, so whether it was ground, whether it was floating, that is going to be assigned right here. Okay, and the other thing that we're going to have to pass through is this whole object, and we're going to assign a left side so that once more we're going to get that platform data and get X from it, and add just the px string for pixels, and let's do the same for the top, width and height. So top, width and height. So platform data Y, platform data width, and platform data height. Next, let's grab the game area that we picked out previously and use the method of append child to actually add an element inside of it. And we're going to grab that whole platform and just whack it in, okay, for each platform. And finally, we're going to save that to the game objects, platforms. We're going to push that into the array. We're going to push in this whole object, and it's just going to be the element, which is going to have the value of the platform itself so we can keep track of it. And we're going to also just spill out any other platform data that we have. And let's also add an ID to this. I'm just going to put the string of platform in front of it and add the index number. So it'd be like platform 1, platform 2, platform 3, starting from platform 0, of course. Okay, so let's define that function, create element. So once again, just do it outside. I'm just going to do it here. Function, create element. And of course, we pass through the type, the class name, and the styles as an object. So with the element that we pass through, we're going to use document and create element. This we did not write, this already exists from the document API. We're going to create a div. Okay, so we're creating a div in the document and assigning it to the const element. So now let's grab that element and let's assign a class name, which we have passed through into this function. And then I'm just going to use object assign and assign the element style with the styles we passed through. And then we're just going to return the element itself. Okay, so that is our function create element, which we wrote. Okay, this is not the one from the document API. This is the one from the document API. You can see we're getting the document object and getting it from there. Great. So now if we look in here, we have created all those platforms. However, they're all bunched up here. Why is that? It's because we need to add position absolute to them, just like we have with Mario. So back in here, where we have the platforms, we're just going to add position absolute. Okay, for here, for this platform, for the floating platform, and the platform blue. Okay, so now, ta-da, there we have it. We have just positioned all of them on our game board. This is looking great. Let's go back to creating our game. I think next, let's write our show game over function. So I'm just going to uncomment that for now. And once again, at the bottom here, so outside that function, let's write function show game over, just like so. And this is going to be easy. We're just going to grab the game state. We have the game running property on that object. We're going to set it to false. We're also going to get the document, get element by ID. So let's search for the game over title. Let's change the text content of it to be, well, based on if we won or not. So this is going to be a variable. If we won, I'm going to put congratulations, you won. Otherwise, I'm just going to put game over. Okay? So great. Of course, this is a variable we're going to have to define. Some other things that we're going to do is just, I'm going to do get element by ID. This time, let's get the final score. And once again, get the text content. And we're just going to get the game state score. Finally, also get the game over style display block so that we can actually see it. Okay, and the variable one, we're going to actually pass that through into the show game over, which means that here, show game over is true. We'll actually see that element. So let's hide it as a default. So back in here, let's find game over, and I'm just going to put display none for now. Okay, so as a default, it should be hidden, and if we lose, we will display it. Great. The other thing we need to do is write the function clear level. So once again, let's go ahead and define that here, function clear level. All I'm going to do is, once again, get the game area, use document, get element by ID, make sure to spell that correctly, and let's look for game area. And now let's remove all the objects apart from Mario. So objects, values, game objects, flat for each, and then let's get each object, and if object element plus object element parent node exists, well, we just remove it. So this is kind of like a hack way to keep removing until nothing is there anymore. Okay, great. So in fact, I don't really think we need this. We can just do it this way. Let's check that out. Okay, so we're going to do that, and then finally let's clear the array so we can start fresh. So game objects, platforms, let's reset it to an empty array. Enemies, let's reset it to an empty array. Coins, let's reset it to an empty array. Surprise blocks, let's reset it to an empty array. And pipes also. We're clearing everything. Okay, great. While we are also here, I'm just going to write the input handling. So essentially how the Mario moves left and right and jumps and so on. So for that, I'm going to get the whole document and listen out to the entire document with event listener. And we're going to listen out for any time we press the key down on our keyboards. Okay, I'll pass through an event so we know which key. So I'm going to also get the game state keys, and I'm going to pass through the E key code that was pressed. Now, I'm also going to listen out to any time the key is relieved, and then I'm going to put that as false. So we're not pressing down anymore. Great. However, if we press key down and we do press the space button, so if E key code equals space, we know this is a jump. We also want to prevent the default from happening, okay, because we're jumping. We don't want to continue moving, okay? So for example, if we're going left and right, we would move left and right continuously unless we press a space, and then we prevent that default from happening. So that is our input handling. We also need to handle the game loop because we want the game to keep looping. So function game loop if, however, there is no game state game running, so the game is not running anymore, it is false. We just want to return out of this. Otherwise, let's update and request animation frame game loop. We of course need to write the update function as well. The update function is going to be a long one, okay, because it's essentially going to handle all of our game logic. So update game logic function update. So there we go. Now let's also uncomment the game loop that we put up here on the game initialization. Great. So this is what our game looks like at the moment. Can't see much, but we've done a lot of logic behind the hood. Let's go back to our load level function. Okay, so we're clearing the level, we're resetting the player, we're creating platforms. There's a bunch more stuff we need to create. We need to create enemies, we need to create coins, and we need to create supplies box, create pipes as well, and the pipe parts. So let's do that now. Okay, so just after we create the platforms, so that function finishes here, still inside the load level function, I'm going to create enemies. So I'm going to grab the level enemies associated to that level, and for each enemy, let's call this enemy data because it is the X, Y axis data and so on. Just going to use index so we know which one we are working with. And what I'm going to do is define our enemy, and for that we're going to use the create element function that we wrote. So we're going to want to make sure that this is a div, and then let's pass through the class name of enemy. You will notice I'm using backticks as we are going to use some code in here. We're going to get the enemy data type, so whether it's brown or purple enemy will be passed through into here. We'll also then pass through an object that has the left and the top pixels. So let's get enemy data, which is an integer, okay, stored under X, and we're just gonna get the string pixels and add it like so. And for the top, we're just going to use enemy data Y. Okay, so now that we've created the enemy, we're going to append the enemy in the game area like we did here. So append child, pass through that enemy. We're also going to get the game objects, get the enemies array. We're going to push in this new enemy, or each enemy that we create. So as the element, let's just pass through the enemy we created. As the X, we're going to pass through enemy X. That's pretty easy. As the Y, we'll pass through enemy data Y. The width is going to be 20 pixels. The width is going to be 20. The height is going to be 20. We're also going to pass through a direction that we want the enemy to move. I'm going to go -1. A speed, which we set above as enemy speed. and let's give it ID. So the ID is just going to be the string of enemy dash, and we're going to add the index, so starting from 0. We're also going to make the enemy alive true to start off with. Great. So let's use the same logic to now create a coin. So after this is finished, so just here, we're going to create coin. Or coins multiple if there are multiple coins. So once again, for the level we are working with, let's get the coins array. And for each coin that exists, we're going to get the coin data, so the X, the Y, and the so on. Let's get its index. And then once again, let's use the create element function that we wrote to pass through a div. And then I'm just going to pass through the type of coin. And as left, I'm going to just put coin data X and append the string pixels. And then I'm going to also put top with coin data Y. Okay, great. And once again, let's get the game area. Use append child. Pass through the coin itself. Let's get the game objects, coins, push. So we're pushing into that array this object, which is going to essentially represent our one coin. So let's get the element and pass through the coin itself. As the X, we're going to just get the coin data X. The Y, we're going to get the coin data Y. Width is going to be 20. Height is going to be 20. Collected, we're going to start off with being false and change it to be true. The ID, well, we're going to do coin and then the index. Great. So just the surprise box and the pipes next. So same logic once more. You'll really get the hang of this soon. Create surprise blocks. Let's get the level and the surprise blocks array, and for each block data, let's get the index as well. So starting from 0, we're going to use the create element function we wrote. So this is a great function, it's getting a lot of use. And then let's just pass through the string of surprise block, just like so. And once again, let's pass through the styles. So left is block data X plus pixels. Top is block data Y plus pixels. And then game area, append child, the block itself, so it shows up in the game area. And then game objects, let's just update this, game objects, surprise blocks, push this whole object to represent one surprise block. We'll get the element, which is the block itself that we defined. The X is the block data X. The Y is the block data Y. The width is 20. The height is 20. The type is the block data type. Okay, so that's going to say coin or mushroom. It's not going to look like a coin or mushroom, or just look like a surprise block, however. And let's start off with it being here as false. And then let's just give an ID. So I'm just going to go with block plus the index. So let's just look at this at the moment. Let's see if we made any mistakes. So enemy here. Okay, so this is looking good. So now if I refresh this, ta-da, we get our enemies, we get our coins, we get our surprise block. However, they're just stuck in here. Why? Because we need to add a position absolute to all of them. So in fact, let's go back up here. I'm gonna go with enemy here, coin, surprise block hit, pipe top right, pipe top bottom, pipe bottom right, and great. So now if we refresh this, they will appear in their correct positions. I love it. This is looking so good. Now let's do the pipes. So once again, right after this, but still in the same load level function, let's create pipes. Once again, level, so let's get the pipes associated with that level, and for each pipe data, so the X, the Y, and so on, let's also grab the index. I'm going to use the create element function and just pass through that I want to create a div, and I want to give it the type of pipe, and these are the styles I want to add. So left is going to have pipe data X plus pixels, and top is going to have pipe data Y. So that's for the whole pipe itself. However, we need to also create the pipe parts. So still inside this function, let's define pipe top left equals and create element once more. This time I'm just going to pass through that I want to create a div, and pipe top is going to be the type, and then let's do pipe top right, pipe bottom left, and pipe bottom right. Okay, so pipe top right, pipe bottom is the style name, and pipe bottom right. Great, so now let's append this all to the pipe. So let's grab the pipe itself that we created above, and I'm going to use append child to put in the pipe top left. We can just use append, in which we can just pass them all through. Pipe top right, pipe bottom left, and pipe bottom right. And once that pipe is created, we get the game area, and we use append child. This is just one to append that whole pipe with all of its 4 children. Okay, so it will look like that. So there's our pipe top right, pipe bottom right, all in one space, all as children. We're gonna have to space them out a little bit. But for now, let's also get the game objects, pipes, and push the element pipe. X is going to be pipe data X. Y is going to be pipe data Y. Width is going to be 40. Height is going to be 40. And the ID is going to be pipe plus the index value. Great. We have finally finished our load level function. I love it. Let's get to spacing these out a little bit more. Okay, so back in here, we're going to have to assign a top and left value for inside the pipe itself. So everything lives in the pipe, but with position absolute, we can actually position the pipe top right, pipe bottom or pipe bottom right inside the pipe itself. So that's why I'm going to say top and left 0 for pipe top, top 0 and right 0 for pipe top right. Then we're going to have pipe bottom as bottom 0, left 0, and also bottom right as bottom 0, right 0. Okay, and that simply means that it will position out the pipes so they look more like this. I'm just going to get this image to see what that looks like. Okay, so it is cutting off a bit of the image, pipe top right. I'm just going to increase that top to top 320. I think it should be a bit lower, so let's go ahead and do that. So here, where do we add that? Well, it's going to be in the levels. So where is the pipes? Let's change that to 320, and it'll probably be the same for the second level too. So I'm just going to change that to 320 as well. Great. And that just means that now it will show up in the right place. I love it. Same for Mario. We can also change where he shows up. So maybe let's go with Y320. And same for here. When we reset the player, it should be 322. Okay? So that's where he will be. We probably need to go even lower than that. So player Y 340, and once again at the top, player Y 340 as well. So ta-da, now he's on the floor. So if you never need to position anything, that's how you do it. Great, I love it. Let's continue. Okay, so now let's write some game logic. So let's go all the way down here and once again work on the game logic function. So first off, we're going to handle the inputs. We're going to support simultaneous movement and jumping. So we're going to use the game state keys for this that have been saved. If, and then we're going to look into the game state object that we have saved above and look at the keys property. And if the keys property contains arrow left, so us moving left, or key A, because we're going to do the WASD movements as well, so you can move with your arrow keys, or WASD, so either one of those, we are moving left. We're going to get the player and velocity x equals minus the move speed, okay, because we are going left. Else, if, and I'm simply just going to copy this, I'm going to go arrow right, and then the key D is for moving right. Then we're going to get the player velocity, but just move at the move speed. Okay, so we've done left and right, else there's just friction. Okay, so we're going to apply friction, and friction is going to be 0.8. Okay, but it's going to multiply, so it's going to get harder and harder to move, just like that. Friction. Wonderful, so we've just used the multiply operator here too. Next, let's handle the jumping. So this handles left and right. And now we're going to handle jumping. So once again, still in this function, handle jumping. Okay, and what we're going to do is say if, and once again, game state keys equals the space bar. So if space bar is in there, and we have to check if the player is grounded because we don't want to jump mid-jump. So we're checking if the player is grounded. So if both those things are true, we're going to get the player velocity y this time. And we're just going to assign the jump force constant that we assigned at the top of our file. Okay, so the player obviously will not be grounded anymore. So we're going to also assign false because he's in the air. And I'm also going to apply gravity. So apply gravity if player is not grounded, so he's in the air, player velocity y is going to increment. I'm going to increase it with gravity. So that's the increment operator right there. We're just adding gravity to it. Okay, and that's going to happen over and over again. Okay, so it will appear that gravity is impacting the jump. So in the game loop, that is where the update function is being called. And then in initializing the game, so all the way here, the game loop is being called. And down here, the initialize game function is being called. Great. So now let's just go console logs out so we can see what's going on under the hood. And here, just going to console log out the game keys so you can see which game keys are being pressed, and refresh. So as you can see, if you press on the arrow left, it will say left, and if you let go, okay, at the moment it's true because I'm pressing down on it. If you let go, it will say false. Okay, and do it for the other side too. Okay, so it's just collecting every single arrow press you do. If you click the space, okay, it's true. As soon as you let go, it will be false. So we're just collecting all the arrows there. Great, and that is constant. Wonderful. Let's continue. So now we actually need to make Mario appear as if he's moving. And to do that, well, we're going to have to use the update element position function that we wrote that will update the player element position and size. And we're going to just pass through the player element, okay? And then the player x axis and the player y axis too. So make sure, again, that is in the update function after we've written all these if statements. Now, if I refresh, he's still not moving. Why is that? Let's have a look. Because we're just passing through the player element, the player x and the player y axis. We've actually updated the velocity, which then needs to translate to the player position. So whatever the player x position was, we add the player velocity x. And we do the same for the y-axis. So whatever y was, we add the velocity y to it. And this will essentially update player position. Okay, so now let's have a look. Let's refresh. And Mario seems to be dropping somewhere down there. Whoa, there he goes. Let's inspect where he went. So here's our game container. Here is our game area. There is Mario. Okay, he's dropping from the top. He's dropping and dropping and dropping. We need to essentially ground him somewhere. So add a platform collision. So let's maybe go back and work on that first. So let's say platform collision. And then let's do it for every platform. So let platform of game objects platforms. So we're saying for each platform in the game object platforms. Okay, so this is just a loop that we are doing. If check collision. So this is a function that we are going to write. I'm going to pass through the player. I'm going to pass through the platform. Okay, so we're looping. We're checking if every single platform that exists against our one player. And if that is true, we do something. So let's write the check collision function. Let's do so outside of this game. So here perhaps function check collision will pass through rectangle 1 and rectangle 2, because it can literally be any rectangle. We'll pass through element 1 and element 2, because it could literally be anything. And we're just going to check the x coordinate of the elements and the width, as well as the y coordinate and the height, to make sure that areas of the two elements overlap. So we're going to return element 1x, and if it is smaller than element 2x, plus element 2 width, and that is true, plus element 1 x plus element 1 width is larger than element 2 x. So if that statement is true and this statement is true, and let's do the y-axis now as well. So let's check element 1 y is smaller than element 2 y plus element 2 height plus element 1 y plus element 1 height is bigger than element 2 y. So again, we are checking if all of these statements are true. We know there is a platform collision that has occurred. Okay, so if platform collision has occurred, well, what do we want to do? Check first if the player is falling. So player velocity y is larger than 0. This means that indeed they are falling. So we want to stop them from falling essentially. So player y, we're going to have to override with platform y so that the player stops on the platform. But then we're also going to minus the player height, because otherwise the player and the platform will appear on top of each other. No, we want the player to essentially appear above it. That's why I'm also subtracting the player height. Now we're going to get the player velocity y and just reset it to 0. Okay, and then we're going to add player grounded as true. Okay, so that the player will stop. So now this should fix our problem of the player falling through, and there we go. So once again, if I refresh, Mario doesn't fall through the ground now because he is on a platform. Okay, and now if I do that, he can also move around. So left, right, jump. This is looking wonderful. I'm so happy with this. We have now made Mario move on our board. Great. However, look, if we go off a platform, he doesn't appear to be falling. This is because we need to actually reset before the platform collision. Let's just reset player grounded to be false so that he continues falling as a reset, okay? As a reset to everything. So by default, he should always be falling. Okay? Wonderful. So now if we do that, he will fall back down. Wonderful. Let's move on. So now we've done the platform collision, we're going to use the same logic to do a pipe collision. So pipe collision, platform collision. It's going to be exactly the same. So we're going to use a loop for let pipe of game objects pipes if, and then we're going to check collision. I'm going to pass through the player and each pipe in the loop. So we're going to check each pipe, and if we're going to check the player velocity y is larger than 0. This just means we're falling down into the pipe. Okay, so we press down, we want to fall into the pipe, so falling. Well, then once again, we want to get player y and then just assign pipe y to it minus the player height so that the player appears on the right position and not exactly where the pipe is. So once again, we get player velocity y and just clear it to be 0 again. And we're also going to ground the player, okay? So make him stop on top of the pipe. Wonderful. So that's stopping on top of the pipe. We still have some logic to do for him to essentially go to the next level. First, however, let's do enemy. So enemy collisions, but also enemy movement. So enemy movement and collisions. We'll do that in one. So once again, let's make a loop for let enemy of game objects enemies if no enemy is alive. So we're checking if any enemy, so we're looping again. If the enemy is not alive, then you continue. Otherwise, we get the enemy x-axis and we use the AND operator, so addition operator, to get the enemy speed and multiply by the enemy direction, because it's going to change direction. So this will allow us to make a move either minus or plus the speed. Okay, now we need to actually change that direction. So reverse direction at platform edges or boundaries. Make sure to spell boundaries correctly. Boundaries. So for let platform of game objects platforms. So we're checking the array of platforms, and if enemy, so we're still working with one enemy, remember this is still in the loop, x plus enemy width is larger than or equal to x. So if that is true, all four of these statements are going to have to be true to recognize that there is a collision with the platform, an enemy with the platform. So enemy x is smaller than platform x plus platform width. So if that's true, and now we're just going to do the same for the y-axis. So enemy y plus enemy height is larger than or equal to platform y plus enemy y plus enemy height is smaller than or equal to platform y. Okay, so if all of these things are true, we do have a collision. So we are on the platform, so I'm just going to say platform on platform true, and I'm just going to create a variable here for on platform, just so we can store it outside of this loop on platform and start off with it always being false before checking this loop. Great, and then we just break out of this. Okay, so now we can write if we are not on the platform or enemy x is smaller than equals 0, so at the boundary edge of our game board, or enemy x is larger than or equal to 800, so at the right hand border of our game board, we know a collision has happened. So let's make enemy direction switch. And a nice way to switch from essentially 1 to -1 or -1 to 1 is multiply by -1. Great. Okay, and now of course we update the element position. So we did it for Mario, now we do it for the enemies. So let's pass through the enemy element, let's pass through the enemy x-axis, and let's pass through the enemy y-axis too. So now if we refresh, it seems the little enemies are on the platform. They're kind of overlapping, so I'm just going to jiggle this a little bit and put -5 here on the y-axis, +5, just to omit that little bit where they are overlapping, and great. Okay, so this is looking wonderful. Now we need to do the, let's check the, yep, and they bounce back, they changed this direction. Let's do the enemy player collision now. So let's go ahead and do it. So once again, still in this function, we're going to do a player enemy collision. So check player enemy collision. So we're going to use the same function that we've been doing, check collision. We're going to pass through the player, we're going to pass through the enemy. And if player velocity y is larger than 0 and player y is smaller than enemy y. Okay, so basically the player is falling because velocity y is higher than 0, and the player is also, so this also has to be true, the player is lower than our enemy on the game board, right? Because player y of the player and the y of the enemy is what we are checking. Then essentially we are jumping on the enemy. So jump on enemy. And if that happens, then the enemy alive is going to switch to false. We're going to remove that enemy. So element remove. This is a JavaScript method to remove the element from the board. Then we're going to do player velocity y is going to be the jump force multiplied by 0.7. Okay, so the jump force is going to slow down, and then the game state score, let's just add 100 points. Okay, so 100 points for jumping on the enemy. Great. Else, we're hit by the enemy, so hit by enemy. So then in that case, we just want to essentially, well, let's check first if the player is big, right? Because if he's big, he just gets a little bit smaller. So player big is going to go to false. We're still to write this function, but you know, we have the big property on the player, so it's easy to know what to do. Player big timer. Let's reset that to 0. Player element class list. Remove the class list of big from Mario, so he just appears normal. And then let's change the player width back to 20 and the height back to 20, because if he's big, those should be 40 as well. Okay. And then else, so if he's not big, we lose life, but we are yet to write that function. So I'm just going to comment that out for now. Great. Let's change how I spell enemy here too. Okay, great. So again, still in the function of the update function. As you can see here, we are still in it. We also need to work on coin collection. So this is another loop for let coin of game objects coins if, and we're going to check the coin because we're checking all the coins in the coin array. So if the coin is not collected, because we're going to mark it as collected if it is, and there is a collision between the player and the coin, so check collision player coin, well then you want to change collected to true, right? Because it is collected now, and I'm going to remove it. So coin element remove game state score plus 50. So you only get 50 for a coin, and that is it. Now let's work on the surprise blocks. So when we interact with surprise blocks, okay? It seems we made a little typo here, so let's change that. So once again, another loop for let block of game objects surprise blocks if the current block that we are looping over, because there may be many blocks in the surprise block array. So if the current block we are looping over is not hit, this means not, and we check collision. So is a collision between the player and the block that we are currently looping over for. And so these three things need to be true. The player velocity y is smaller than 0, block hit equals true. We hit the block, and then we're going to change its class list, so it changes visually. Block element class list add hit. So it looks like it's been hit. Okay, so for now, let's see what hit looks like. Essentially, we're just changing the image here, so that is good. Let's go ahead and trial it. So I'm just going to refresh here for now. Make sure player is spelled correctly there. So let's just go ahead and refresh for now. So here we go. I'm jumping. I'm killing the little enemies. Collide with a coin. I get the coin. We need to update the score too. And now let's check for a collision. So annoyingly, that block is under there, but amazing. So when we collide with the block, it changes to a hit block instead, rather than one with a question mark. So that is looking good. I love it. We can, of course, move that to be here as well. That is something that I will do later on when we are refining the game. But for now, this all looks good. Let's just check we can land on the pipe as well, and we can. I love it. Okay, so let's continue. Now, of course, if we hit the block, we're not quite yet done, because if we hit the block, so if block is hit, we just say true. We can also check the block type, because our block object has a type assigned to it, if you remember, and it could be that it has the type of mushroom assigned to it. And if it's mushroom, well, you know what to do. We need to make the player big. So player big is going to be true. Player big timer, we're going to set to 600, so 10 seconds at 60 FPS. The player element class list, we're also going to add. So add big to make our player big. So for 10 seconds, our player will be big. Let's also change the width of him to be 40. Actually, maybe let's make it 30. Maybe double is a bit too much. Again, you can rejiggle with this as much as you like. So I'm changing the width and height. The game state score. I'm also going to add 100 for getting a mushroom. Then else if the block type was the other block type, it could be equals, so dbl equals the string of coin. Well, I'm just going to add a score of 50. Okay, great. We should also have some kind of visual to show that a coin has been hit. We can work on that later. But for now, let's check if he does in fact become big. So once again, I'm just going to refresh. And I think this is a mushroom. Ah, great. So amazing. We've multiplied Mario, however. Why is that? It's just looking quite funny that there is 4. Let's have a look why. So Mario class big, styles. Let's search for big. Okay, 30. So it's up to you however you want to do it. I obviously changed my mind and went from 40 to 30. Let's have a look. Okay, so there we go. However, the Mario is not, image is not covering the element like I want it to. Just going to zoom in for you here a little bit. So Mario big. On Mario itself, I'm just going to do background size cover, no repeat. So now, let's check it out. Ta-da, there we go. Mario is big. We've fixed that problem. Great, let's continue. We have one more interaction to do, and that is for pipe interaction to next level. Okay, so once again, let's check for any pipes, because there could be more than one pipe. Pipe of game objects. Pipes, this means that when you create future levels, you don't have to worry about anything. You can add as many pipes as you want. They'll all take you to the next level. If player grounded, so if he is grounded on top of the pipe, and player X plus player width is larger than pipe x and player x is smaller than pipe x plus pipe width, and we want to make sure that he's standing on top of the pipe, the whole pipe. I'm going to use math abs to get the absolute number, okay, like a rounded number, and I'm going to get player y plus player height minus pipe y. So this will help us check if he's standing on top of the pipe and it's smaller than 5, and we also want to be pressing down, right? So game state keys, and the current key that's being pressed is arrow down. Okay, if all of that is true, we go to the next level and call it. Of course, we haven't written that yet, so I'm just going to comment that out. However, this should be like that. Okay, so if all of that is true, then we go to the next level. I love it. However, I'm just going to go up here because check for enemy interaction. So enemy movement and collision, actually, this should have inside of it, check enemy player collision, not the coin collection or the surprise blocks, however, or the pipe interaction. So I'm just going to take those three functions, close this up now, and paste those three above the update element position, still inside the update function. Okay, so just like that. Please refer to my code that I have added if you are not sure. Okay, now we're just going to do two more things before we go out of this function of updating fall death. If player y is suddenly larger than 400, then we lose life. So once again, that is a function that we are yet to write. And finally, let's just update the UI with the score and everything. So we can use document get element by ID. And we're going to get the score. So we can update the score visually. You can use text content to do this. Game state score. Okay, so whatever the game state score is going to be assigned to the element of score in our UI. Let's do the same for the level and the live. So just change this to level and this to lives. And then this level, so this is something that lives inside our game state object and lives. Great, and we are finally done with the update function. Let's write our next level and lose live functions next. Okay, so down here, function lose life. Well, the game state does store lives, so we're just going to minus that from it. And if game state lives, so for example, you have 3 lives, this operator will remove 1, so it will come to 2 lives. And if game state lives suddenly is smaller than or equal to 0, well, then there's no lives, right? So we show game over. And because we didn't win, we pass through the one variable as false. Go back to the game over function if you need to see the one variable to refresh your memories. Else, we reset the player position. So player X is going to go back to being 50. Player Y is going to go back to being 300. Of course, we need to make sure that this is aligned with what we originally set. Player velocity X is going to go back to being 0. Player velocity Y is going to go back to being 0. Player big is to go back to being false. Player big timer can go back to being 0. Player element class list, remove any class of big. Make sure that is spelled correctly. And let's set the player width back to being 20. And so the same with the height. Wonderful. So that is our lose life function. We can uncomment where we have used it. And we're also going to write a function for next level. So this is going to take us to the next level. And all I'm going to do is get the game state level. So if it's currently 1, we'll change it to 2 using the addition operator. And then if game level is larger than level's length, well, I think for now we'll just show the game over, okay? But you can loop this if you want. You can add more levels, game over. I'm just going to add a game over for now, however. Sorry, this should be of course game state because level lives in the game state object. Else, we go to the next level. So we use the load level method that we wrote or function. And we get the game state level and minus 1 from it. Okay, great. Make sure that says next level like so. Okay, so now let's uncomment those out. Uncomment lose life here, uncomment next level, and uncomment lose life there. This is looking good. Let's have a go. Okay, so now if we kill, we get a score of 100. That is great. Let's just check that works again. So once again, score of 100. And if we get a mushroom block and turn big, again, that has been updated. We are still on level 1. We've got 3 lives. So let's try go to the next level. So if we land on the pipe and go down, press down, ta-da, we are right here. This is looking good. However, I'm starting a bit higher. That is something I'm going to have to adjust. Let me just check first. Okay, so here something strange is happening. We will have to figure this out. And ta-da, congratulations, you've won. So that's our score. We can play again. So to me, this is looking wonderful. We, of course, probably need to attach some functionality to the play again button. So maybe let's write a function called restart game. Okay, function restart game. And then all I'm going to do is set the game state to be whatever it was, as well as. So once again, what I am going to do, so we can just scroll all the way back here just to make sure that it is the same. We'll get the game state. So this is the reset essentially. We'll scroll all the way down here and just paste it like that to make sure it's exactly the same. We'll then also, so just like here, reset all of these things. So I'm just going to copy that and paste it here like so. And now let's grab the restart button. So document get element by ID, restart button, const restart button, and then we'll grab the restart button, add event listener, click, and then call the function restart game. Okay, I'm just going to move that to be down here. Wonderful. I'm happy with that. So the X and Y axis after you lose a life is 50 and 300. I just want to make sure that is the same for here. It's actually 340 here, so let's change that down here. 340, and let's try play again. So great. This is really, really fun. Of course, you can mess around with how fast and how slow all these enemies are. So some of the images are a bit bigger. I'm just going to do cover, just like we did with Mario. So where is Mario? Cover, background, repeat on some of these too. So on the enemies, there we go. And I believe also on the pipes. So pipe top, pipe right, pipe bottom, pipe bottom right. We didn't quite finish writing this, so restart game. Yes, reset everything. Let's also get rid of the game over element. So still in the function document, get element by ID, game over, style, display, none. Make sure, of course, to do game over exactly how it's written here. Okay, and then initialize game again. One thing we can do is actually just simplify this. So remove that and do that, just so it's in the same format. And great, so now if I get killed, game over, play again. Wonderful. So yes, this is looking good. Amazing. This is super, super fun. So now I'm just going to go to the next level. And once again, we probably need to put cover fit on some of these images and just adjust a little bit where Mario is landing. But otherwise, this is looking good. Okay, so back in here, I'm just going to add background size cover. Let's just do it to all of these just to be sure. So it was platform. We need to do platform background repeat. Let's do it also for the floating and platform blue. And finally, let's just move the where this little question mark is displaying. So that is easy. We just go to the game board. So level 1, the coin. Well, there's 3, there's the surprise block. So I just want to move the surprise block higher and maybe more to the left. So let's go ahead and do that. I'm going to go x-axis 320 and then just add maybe 120. Okay, maybe that's a bit too high. Let's go with 180. Okay, so that is looking better. That's how you would move yours around as well. So if we go here, ta-da, he is bigger. And these should be for coins. I'm just going to change this to background size instead. Same for the platform ground and put background repeat. Same for platform blue. So background size repeat. Same for here as well. Okay, and that looks much better. I'm happier with that. Okay, we have one last thing to do to really take this game to the next level, and that is spawn either a mushroom or a coin if we interact with the surprise block. So I'm going to do that, let's say here. And the function we're going to write, so function is going to be called spawn item on box. There we go. And of course, we're going to pass through the block and the type. So spawn. First, we're going to create a new div to represent the item. So it's either going to be a mushroom or a coin. So we're going to use document create element div, and that div we're going to assign to the const item. Next, we're going to grab that item. Of course, at the moment, it's not on our board or anything like that. We're going to add class list, so class list add, and the type. So if you remember, the type will either be a mushroom or a coin. Scroll back to the top if you want to familiarize yourself with this again. Next, we have to position that item. So item style on the left, we're going to assign the block X value. So wherever the surprise block is, and just add pixels because we want it to be exactly where the surprise block is. So that is horizontally. And then we also need to do this on the y-axis. So item style top, just like so. And this time we get the y-axis. So block y, however, we want it to be slightly above the block, so exactly 20. The block is 20 height, so it will show up above the block, and then we add pixels, just like so. And then of course we need to add that element to the game area so it's visible on the screen. So let's get the game area, use the append child method, and pass through the item. Great. Now we're going to create an object to keep track of the item's properties and physics. So const item object equals, and then of course we have to make that an object. So the x is simply going to be where the surprise block currently is, so we're going to use block x. The y of the object, so the mushroom or the coin that's about to sprout on the y-axis is going to be y minus 20, because we said we want it to be above the block. The width of it is, well, going to be 20 because we're keeping everything consistent. The height is going to be 20 as well. The element is going to be, well, the item itself. So this that we created after all of this has been applied, and the velocity y, so how it's falling, so the vertical speed, we're going to start off with being 0. Now game area is not defined, we must have picked it out in the scope of another function, so I'm going to pick it out here. Let's do it at the top. So document get element by ID game area, so we can pick out the game area of our game and save as the const game area, because that's where we're going to be putting in this item into the game area. Great. Now, after this object has been written, but still in the spawn item object function, we're going to check if the type is a mushroom. Because if it's a mushroom, we want it to do one thing. To be precise, we want it to fall. Else, if type equals coin, we don't want it to fall. We actually want it to rise. So kind of float in the air. So I think that coin is easier. Let's do that first. And we're just showing something visually, right? So all I'm going to do is let frames equal 0, because we're going to start off with the frame counter being 0 to remove the coin after 3 seconds. And now I'm going to create an interval to animate the coin floating up. So const float interval equals set interval. And then I'm simply going to get the item object y and minus 1 to it. So it goes up. And then I'm going to get the item style top. So this is applying it visually, right? This is not visual. This is the visual part. And I'm going to get the item object y after I add minus 1 to it and just add pixels. Great. And then I'll increase frames plus 1. Now let's stop it. So if frames is suddenly larger than or equal to 180, I simply want to clear the interval of float interval, okay, and remove the item. So item remove, just like that. And I want this to run every 16 milliseconds, so roughly 60 frames per second. So I'll just put that there. Wonderful. So that is our coin object. For now, I'm just going to console log out the word mushroom here so we can test it out. So where do we want to spawn the object? I'm just going to copy that. Well, I guess after we collide with a surprise block. So let's check for the surprise block collision. So here we go. After block hit true, yes. So irrelevant what it is, we're going to spawn an object. We're going to pass through the block, that's right, and the block type. So the type is actually attached to the block itself. Great. So let's go back to here. So here we go. Let's test it out. So let's find one that's a coin. So it should be here. And great, our coin is indeed floating up. I love it. Let's just check we got the right amount of points as well. So Let's go back here, 100, and ta-da! Yes, we did indeed get points. So this is looking good to me. We got 50 for that one and 50 for that one. Everything is looking good. Let's work on the mushroom next. Okay, so if mushroom, just going to delete that so we can work with it. First, let's work on showing it visually. So I'm going to create another for loop. So const for interval equals set interval, just like so. We'll get the item object velocity y. And this time, because it's falling, we're just going to use our gravity const. Okay, so apply gravity to increase downward velocity, and then we'll move the mushroom downwards according to its velocity. So we're simply going to get the item object again, y-axis, and add the item object velocity after we just changed it above. So velocity y. Great. Now let's check if the mushroom has landed on a platform. So let's start with on platform being false to clear everything. And we're going to have to check for a collision with the platform. So once again, there are many platforms that it could collide with. So let's loop over them. So let's get the game objects, and let's get the platforms array, platforms, and if, okay, so here we're going to do some more logic. We're going to check for a horizontal overlap, and then we're going to check for another horizontal overlap, but this time checking the width of the item object itself. Then we're going to check the bottom of mushroom at the platform top, and then also allow a small tolerance. So if there is a collision, we know that on platform has to be true. And then what we're going to do is position the mushroom on top of the platform and stop the downward movement, because at the moment it's falling. Item object velocity y equals 0, and then we'll break. So exit the platform loop. Wonderful. But still inside here, so after these two parentheses, we need to update the DOM element to match the new y position. So actually show it. So we're going to get the item style top, item object y, and add pixels to it. So we can see the mushroom visually. And if on platform is true, we're going to stop the mushroom falling, of course, but we also need to clear the interval from running. So clear interval fall interval. Great. And we want this to run every 16 milliseconds again. So wonderful. This looks good to me. The one thing we do need to do is add a mushroom style. So I'm just going to go ahead and do that now. The style name of mushroom. Let's just copy this, so just like that, and add a background image. Again, I've already uploaded these onto Imager a while ago. So here we go. So let's test it out. So now if I interact with this, ta-da, a mushroom falls down. Now in my game of Mario, I'm just going to actually remove the mushroom when it hits the ground. I'm happy with this. Of course, you can take this further. I will leave a little note at the end of this video for you. For now, however, you might be noticing some lag. For example, if you're viewing this the next day or in a different browser, I'm going to actually remove these set intervals so that everything is consistent with working with the request animation frame. So this should get rid of any lag, and your Mario should be moving at the same pace. So to do this, all we're going to do is just write a function called for, like so, and I'm simply going to take everything from the set interval, everything, and remove the set interval and paste that code. So that is now all in the for function, and I'm going to remove this too and put request animation frame and pass through for, and reverse this. So when we're not on the platform, this gets called. Great. And let's call the for function. Let's do the same for the coin now. So once again, let's write a function called float up. And I'm going to remove the frames. I'm going to take all the code from the set interval, delete the set interval, and once again, just change this to be requests animation frame and pass through floating up, as well as just make sure that that is attached to the object. So item object was, item obj, remove this item remove and put that in an else because we need to reverse this. Okay, so I've just reversed that. This time we're checking if it's above 180. Okay, if it's above 180, we call the request animation frame function. Great. So that is now much more consistent. I'm just going to add frames to my item object. Okay, and great. Okay, so there's one fix we need to do. When we go to the next level and Mario is big, he appears to be floating. Let's get rid of that. So let's remove big and reset the player width and height when he goes to the next level before loading the game. Done. Okay, good. One more thing we should do, there is a weird glitch, say if Mario is big and he gets hit by an enemy, because he gets made small so quickly, the enemy's still there so he loses a life. No, let's get rid of that. So I'm just gonna check if the player is grounded as well, so not falling, and that should fix that glitch for us. Of course, feel free to take this further if you want to then have the mushroom move and Mario chase it and only grow big once he eats the mushroom. That is totally up to you. I'm just going to stop here for now. My intention was to, of course, help you practice JavaScript and take this game, take it to the next level, add more levels, add different functionality, you name it. Okay, so please, again, if you want to fork this project and take it on, go ahead, it's up to you. Hopefully you're happy with it in the state that it's in, and I produced a cool game for you while we practice our JavaScript. Okay, so wonderful. I hope to see you again on here soon.